So we're going to talk a little about how to simplify a radical expression. So a radical expression, for those of you who may not know what I'm talking about, is anything with a radical in it. So for example, the square root of 3, 2 times the square root of 12, 8 times the square root of 6. I could go on and on. So this is considered a radical term because it has a radical or a square root in it. Same thing goes here and same thing goes here. So when we talk about simplifying a radical expression, there has to be two things that are true. Number one, the radicand, or the number that is inside the radical, must not have any perfect square factors. Number two, there cannot be any radicals in the denominator. So what I mean by that is, for example, 1 over the square root of 3, that would not be considered to be simplified. And so what we need to do here is talk a little bit about both of these cases and how you would go about simplifying it. Let's start with the first case. So the first situation says the radicand, or the number inside the radical, must not have any perfect square factors. So in order to build a factor to figure out if, like, let's say example A is 32, when I break 32 down and look at its factors, the best way I like to do it is look at a factor tree. So if I break the square root of 32 down, there's many different ways, but the first one that comes to my mind is 2 and 16. I'm going to stop right there because I know that 16 is actually a perfect square. And so one little side note you do need to know is you need to know your perfect square factors. So I'm going to write the first 10 up here right now. So it's 1, 4, 9, 16, 25, 36, 49, then we have 8, we have 9, we have 10. And actually I can write the next couple since I have some space here. That's the first 12. I would say if you know the first 12, then you're in pretty good shape. Okay? So if I break down the square root of 32 as 2 times 16, that means the square root of 32 is equal to the square root of 2 times the square root of 16. Well, I know the square root of 16 is 4. And so really the answer to this is 4 root 2. 4 times the square root of 2. That's my simplified answer for the square root of 32. But you may be asking yourself, well, what if I chose a different pair of factors? What if I chose 8 and 4? So let's take a look at 8 and 4 briefly. So if I chose that, once again, I can stop and say, whoa, I found a perfect square factor. That's 4. And so you would say, Mr. Fugay, the answer is 2 root 8, which is different than what you had, what I just did. So what's wrong with this? Well, the problem is 8 can still be broken down. 8 can still be broken down because 8 is 4 times 2, and look, there's another perfect square factor. So how are we going to avoid this happening? Because this can get mighty confusing, especially as we look at some higher numbers. The best way I would think about it is break it down, your problem, as much as you can in something called prime factorization, meaning break everything down into your prime factors. So when you do that, the square root of 32, let's go back to the 4 and 8 example. 4 technically breaks down as 2 times 2, and 8 breaks down into 4 times 2. But then we also know that 4 breaks down into 2 times 2, and so I can't break this factor tree anymore. Now, you may want to pause the video for this, but the 2's down here, all of these 2's, that's the prime factorization, basically meaning if I multiply 2 times 2 times 2 times 2 times 2, I'll get my original problem, which is 32. Try that out if you want. But basically now what I want to look at is this. The different way to look at this is say, okay, let's look for a pair of numbers that are the same, because a pair of numbers that are the same is the definition of what a perfect square is. So for example, I have this pair of 2's and this pair of 2's. That 2 right here, this pair represents a perfect square, and this pair represents a perfect square. So when I take this to the outside of the square root, I have to take its square root, of course. 2 times 2 is 4, and the square root of 4 is 2. 2 times 2 is also 4, and the square root of that 4 is also 2. So we'll connect it with multiplication. Now this 2 right here that I'll circle in black didn't have any partners. Nothing that it could be a perfect square with. And so that's going to be left inside the radical. And so we call that square root of 2. My final answer here is, again, 4 root 2 like we've had before. So let's try one more example, and then I'm going to have you try these other two yourself. So let's look at the 640. Now, once again, strategic values are going to make this a lot easier for you. For example, 640 is a really large number. If I choose 640 and let's say 2, I can break it down and say, oh, it's 2 and 320. And 320, I can break it down and say, guess what? It's 2 and 160. And what can I do with 160? Well, I can make it 2 and 80. 2 and 40. This seems like there's an easier way to do this. And as you can see, I'm writing this all the way out. But instead of doing this, why don't we look at the number 640 itself? And because we know our perfect squares, what would be a number up on our perfect square list here that we could use as a factor? Pause the video if you need more time, but I think the right answer is 64. I know that 64 times 10 is 640. And I've made this now a lot easier on myself. I can break the 64 down now to 8 and 8. There's your perfect square. 10 breaks down, let's just make sure, to 5 and 2, and I can't break it down anymore. Now you may say to yourself, well wait, can't I break down these 8s? Well, yes you could, but you do know that that is a perfect square. 8 times 8 is 64, and the square root of 64 is just 8. So the outside number I'm going to have is an 8. Now on the inside, I have to write whatever I have left over. The 5 and the 2 didn't have a pair, so I couldn't find a pair up to make a perfect square with them. So I'm just going to multiply them back together to give me 10. And so 8 root 10 would be my simplified answer for part B. This time I'm going to ask you to pause the video and try letter C and letter D. After you tried them, resume the video and I'll have the solutions up. So what I've done with these last two examples is I've written out the factor tree for them. Now for the square root of 196, what I've noticed is I have a pair of 7s, which represents a perfect square, 49. And I have another pair of 2s here that also represents another perfect square, 4. So if I move these to the outside, this is 4 and the square root of 4 is 2. I move this to the outside, the square root of 49 is 7. And I actually don't have any other perfect squares or any other terms at all. I've used every term. And so what actually end up being is the answer to this is 14. And one thing you may not know, I only went up to 12 in my perfect squares. 196 is a perfect square. It's a perfect square of 14. And so if you don't memorize all your perfect squares, your higher ones at least, you're still going to be okay when you have to break these down because things like this will happen like letter C. Lastly, for letter D, something also happens. When I break it down, I get 5 and 6, and the 6 breaks down to 3 and 2. Now my factors are 5, 3, and 2, none of which are pairs, which means I don't have any perfect squares. So the answer to this, very simply, is just going to be the square root of 30. Sometimes you are not going to find any perfect squares. The rule just simply says, to simplify, you can't have any perfect square factors. Well, this one didn't. And so the square root of 30 is a simplified answer that we can go with. The remainder of this video, we're going to talk about the second rule, which is that there cannot be any radicals in the denominator. And so all of these examples have radicals in the denominator. And so what we're going to do is a strategy that we are going to use, because I know that the square root of 2, if I multiply that by itself, gives me the square root of 4. And the square root of 4 is just 2. So if I were to multiply my part A by the square root of 2, well, that will give me no more radical in the denominator. But I can't just multiply something by root 2 in the denominator and not affect it. I have to multiply this by the number 1. Because by multiplying something by 1, anything times 1 is anything. And so if I multiply the bottom by root 2, I'm going to want to also multiply the top by root 2 as well. Because now, in the red, it's the equivalent of multiplying by 1, which doesn't change the value of the number. So when we multiply this out, I get 1 times the square root of 2, which is just the square root of 2. Down the bottom, I get the square root of 2 times the square root of 2. That's just the square root of 4. The good news is the square root of 4 is a perfect square. It's 2. And so here would be my simplified answer. Root 2, or square root of 2, over 2, that's a simplified answer that is the exact same value as this. If you plug this and this into your calculator, you should get the exact same answer. That's a good way of knowing if you did this correct or not. Let's try one more example. Let's look at part B. So if I want to get rid of the square root of 2 in the denominator here, once again, I would want to multiply by that denominator, square root of 2. I also would want to do that up top as well because, again, I'm multiplying by the number 1. This is the equivalent of multiplying by 1, which does not change the value of the number. Now we simplify. Root 3 times root 2 is square root of 6, and root 2 times root 2 is 4, which we already know from up here is just going to be 2. Now before you circle this, you should double check this, but the square root of 6 doesn't simplify. And so this is indeed going to be my final answer. Pause the video and try part C and part D, and I'll have solutions on it in a few seconds. Here are the solutions to the final two problems. So in part C, I did the same strategy I did with A and B. I multiply by square root of 6 over square root of 6. Up in the numerator, I'm going to get 2 times the square root of 6, and down in the denominator, I get the square root of 36. That's just going to be 6. And so now I have left with 2 root 6 over 6. Like any fraction, we're going to want to simplify this. So this is kind of like 2x over 6, for example. When I simplify that, the 2 and the 6 are going to become 1 and 3, and so my final answer is square root of 6 over 3. Last but not least, I have part D. Now part D, I threw a little curveball at you because the square root of 100 is a perfect square. And so you could have saved yourself a lot of work if you recognized that, because that just means this is 2/10, and 2/10 is 1/5. So don't forget your perfect squares, because if you know your perfect squares, it's going to make the problem much, much easier.